morning, my dear students. In today's class, we are going to see about the execution of weather dataset using the MapReduce program. So, we have weather dataset and we are going to analyze that in which year what was the highest temperature. That means the weather dataset is having the year maybe 1990, and in the 1990 what were the temperatures were collected? 12 degrees, 40 degrees, 36, 26, and again in the 1991 temperatures, and this is my temperature, right. So, what we are going to do is, in the year 1990 what was the highest temperature? Similarly, in the 1991 what was the highest temperature? So, that we are going to find out through writing the MapReduce program. So, first we are going to see how the MapReduce program we have written using the mapper code, reducer code and driver codes, and we will keep the weather data set into the HDFS. After that, we will write or whatever the weather program we have written in Java, that we are going to supply as a jar file to the HDFS where my data set is located, so to perform the analysis. So, let us see how that is going to happen. So, as we know that we are going to work with VMware and the Cloudera, so it is installed in my machine and let us see how it is going to run. So, this is my VMware and my password is as usual Cloudera by default password. So, now we are going to see the program which is going to perform the analysis on the weather data set. So, let us write the program first of all, and after writing the program then we are going to see the data set. So, let us see the program now. So, my program is available in my default directory, that is Cloudera, and my program is, this is my program, temp.java is my program. So, what is this program is doing is, look at here, this is the program is doing here. What is happening is here, you can see here the temperature program, finds out the maximum temperature. It finds the maximum temperature in every year from the given input file. So, what is the input file here? The input file is nothing but my weather data set is my input file. Right. So, the output data is in the form of year and the maximum temperature. So, from this weather data set, it is going to find out the year and the maximum temperature. That means, for example, in 1990, what was the maximum temperature? 36 degrees. In 1991, what was the maximum temperature? 38 degrees. In 1992, what was the maximum temperature? It was 32 degrees. So, in this manner, we are going to get the output, and this output also we are going to get in the form of a key value pairs, right. So, that is what we are saying here. The output data is in the form of year, the output will be coming in the form of year, maximum temperature corresponding to that year. So, we will write a MapReduce coding where we will be having a mapper code, reducer code and driver codes, and the mapper makes key value pair from the input file and reducer does the aggregation job, that is also in the form of a key value pairs. That means, whatever the fundamental concept of MapReduce is there, the same mechanism will be applied. The map method will take the input file and after processing the mapper code, whatever the intermediate output given by the mapper will be in the form of a key value pair, and that will be as an input to the reducer, and the reducer will do the aggregation. After doing the aggregation, the output will be coming, that is nothing but the year and the maximum temperature. Right. So, this is the basic scenario of the temperature program using the weather data set. So, now as we know that first of all we need to import the packages. So, you can see here the packages are, these are the packages are there, these are normal packages we have, that is your java.io exception, java.util.iterator is one package, java.util.string tokenizer. This package will be helpful to make the strings into whatever the lines of code is there, it is going to be broken into tokens, right. For example, we have 19, 90, 30, 40 likewise. So, these are going to be broken as a token. This is one token, another token, another token. So, to break this into tokens, this package will be used, right. And you can see here that is about the normal packages. These are all the packages from the Hadoop packages, org.apache Hadoop packages. So, these packages are necessary for writing the mapper, reducer and driver code. These are your normal Java packages, but these are all very important packages which are used for the mapper code, driver code and reducer code. So, these are the packages are available now. Let us see these packages. So, import org.apache.hadoop.fs.path for path, int variable, long write variable, text, these are all my generic types, file input format, file output format, job client, job configuration, MapReduce base, mapper, output collector, reducer, reporter. So, this reporter is going to show whatever how the process is going to be done, that is called as your report, and text input format and text output format. So, file input format is different and text input format is different. So, these are all the packages which will be from the Hadoop packages. So, these packages are necessary. So, whenever you are using these packages, before executing the program, you need to export the Hadoop jar file, and all these files are available in the Hadoop jar file. So, you need to set the path. If you do not set the path, these are, even though your program is not having an error, but because you have not set the path for the Hadoop.jar file, because these are all the packages available in the Hadoop jar file. So, already in the previous class we have discussed. So, Hadoop jar file, and this jar file is available in root user lib package and in the folder called Hadoop 0.20. So, this package, this file will be available in this path. You can copy this path, you can copy this file and you can place in the current working directory where your program is there. My program is available in root home Cloudera. So, in this my program is there, copy this file and then just paste it here. So, once you do the pasting path and just set the path, then these errors will not come. Otherwise, if you do not set the path, because of these packages, certainly errors will come. So, you need to set the path. So, that is about the Hadoop packages. Now, let us see the class, public class temp. So, since I have given the class name as temp, so I will be storing the file name also as temp.java. Please make a note of this. So, here what I am writing is, in this I am writing my mapper. So, I am just making a comment, interface mapper, map class is a static and extends MapReduce base class and implements the mapper interface, and these interfaces are having 4 Hadoop generic types, and these 4 generic types are nothing but long writable, text, text and int writable. These are called as generic types. So long writable, text and int write variable is a 4 generic types. So these are all the parameters taken by the mapper interface. So that's what about this. So let us see here. Public static class. So I am having a class here. My name of the class is map. Map is my class. Don't get confused. Capital letter M is my class. Small letter m is my method. So public static class map is my class, extends MapReduce base class, my super class it is, and it is implementing the interface that is called the mapper, and the mapper is taking a 4 parameters, that is generic types, that is called as long writable, text, text and int writable. These are the 4 parameters taken by the mapper interface. And you can see here how these are going to work is, so you can see here little bit small changes we are making here. I am defining a local variable, that is called as my k is a local variable of type text. So text k equals new text, so k is my object now here. So we have a purpose for that, so that is the reason we have defined it. And now I am writing my method, my map method I am writing here. You can see here public void map is my method, and the map method is taking a parameters here, generic types long writable, text, and then output collector we have, and these output collectors takes in the form of a key value pairs. This is your key and this is your value pairs. Output reporter is nothing but how the analysis is performing, how the entire sentence or how the entire line is broken into strings. So that is going to be make a reporting. So when you run the program, at the time the reporting is going to be done. So that is your reporter, and then we are throwing the IO exception. That means if you have not passed the required input files or output files, or if input file is not available in the HDFS or the output file is already existing, then you are going to get the IO exception. So we are handling the IO exception, throws IO exception. And I am taking one more variable, string line value dot to string. That means every value I am converting in the form of a string format. So converting the record, whatever the record I am having, into a single line to strings, and strings in a string variable. That means the entire line I am taking and keeping in the variable called as line. And after that what I am doing is, you can see here string tokenizer is a breaking the record. That means whatever the line we have made here, so whatever the data we have, that line is taken in the variable called as a line, and after that string tokenizer is breaking the record. That means this line according to the delimiter white spaces. So whatever the delimiter we are using, so delimiter can be a white space, delimiter can be a comma, delimiter can be a pipe symbol, whatever it could be. So string tokenizer is my object, new string tokenizer line. That means already I am having data in the line. So for example, my file is having my input file is having 3 lines. So first line will go to this line variable. After that, in the line how many words are there? So I am separating the words between using the spaces. So space, so that is the reason I have given here space here, right? So to continue that job, because there will be a number of lines will be there, in the line number of words will be there. So to repeat that job, I am iterating here, iterating through all the tokens and forming the key value pairs. That means in the line there may be a 10 words will be there. So to repeat the 10 lines or 10 words, you need to go for the iteration. So while tokenizer has more tokens, so in the line how many tokens are there? Has many tokens. Next token is there, yes. Next token is there, yes. Next token is there, yes. If token is not there, then loop will be terminated here, right? Next is the first token is going in the year variable of string type. So here I am taking the variable as year and the year I am taking as a string. Tokenizer dot next token. So k dot set, set is a method. So I am setting the year in the k. So k is already defined as a string variable, and you can see here takes next token and removes all the white spaces. So what is happening here? It takes next token and removes all the white spaces around it, then stores the string variable called temp. So whatever the extra spaces are there, that will be removed and that will be stored in the temp variable, tokenizer.nextToken.trim. So if any spaces are there, it's going to be removed. The spaces will be removed, extra spaces, and then it will be stored in the temp variable. After that, convert string into temp into integer v. That means because we have taken the form of a string, but in the weather data set I am having all the integers. So I need to convert it. So how I am converting it? Int v is my variable, integer dot parseInt. ParseInt is my method, and temp, I am passing the temp. Temp is having my string, it's a string. I am converting in the form of integer. Now it is there in the v format, right? It is in the integer format. So sending to output collector, which in turn passes the same to the reducer. So now output dot collect k comma new int write variable. That's nothing but k will be having the year now. K will be having the year. It will be having a year. In the year 1990, there are number of temperatures are there. 36 is one temperature. 36 is one temperature. 37 is one temperature. 38 is one temperature. So that is why int variable v. So now this will be as a key value pairs. And output dot collect. So collect is a method. It's going to collect the k as a year and v as a value. Values are nothing but your temperatures. And this will be given to the reducer. So this is the intermediate output produced by the mapper method. And after that, this output will be, intermediate output will be given as an input to the reducer, and reducer will do the aggregation job. What is the aggregation job? What is our task? In 1990, what was highest temperature? So that job we have to find out now, right? So this is all about our mapper method. Now the scenario of reducer is coming. So reduce class is a static class, and extends MapReduce base, implements the reducer interface, right? And how it is going to happen, look at here. Public static class reduce, my class name is reduce, and it is extending the super class called as MapReduce base class, and it is implementing the interface that is called the reducer, and reducer is taking the parameters that is called as the text. So two parameters it is taking, text iterable, sorry, 4 parameters it is taking, and we are defining a local variable that is called as that max temp is a local variable. Max temp is my local variable. It's my local variable, and the local variable has been assigned with the value called as 0. You can see here I am having a defined a reduce method, and in the reduce method I am passing a parameter text, iterator, and then the output collector, and it is collecting the output, reporter is as usual, and it is throwing the exceptions. So this part is little bit important here, because in this part only we are performing the analysis. So it iterates through all the values available with key if the integer variable temperature. So already the map method has given one key as a year and number of values as a temperature, because in 1 year we have collected n number of temperatures. So out of the n number of temperatures we have to find out what is the highest temperature. So highest temperature duty is done by the reducer. So while values dot has next, for example here the temperature year is 1990, 36 is 1, 37, 38, 39. So values dot as next, I should repeat the loop to the next value, to the next value and next value. If no value is there, automatically loop should break. So that's what I am performing here. While values are has next, and I am defining a local variable temperature of type int, which is taking the temperature. So temperature is my local variable, values dot next get. So the get method, see I have used two methods here. In the map method I have used a set method to set the values, and in the reducer method I am using a method called as a get to get the value. So if max temp is less than temperature, whatever the temperature is there, it is getting the value and it is checking here. Then the max temp is having the value called as 0, which is already I have shown here. So max temp is already assigned with the value called as 0. Now what I am saying now here, if max less than temperature, then if it is less, I am assigning to the max temp. So this job is going to be repeated as long as the values are there for 1 year. After that, it repeats for the next year, it repeats for the next year likewise. And then finally it collects the output, that is called as output.collect key. Key is nothing but the year, and what is the final temperature, that is the maximum temperature. So for the 1990, the temperature is, the highest temperature is, in 1990 my highest temperature is 36 degrees, in 1991 my highest temperature is 32 degrees, in 1992 my highest temperature is 26 degrees likewise. So this is my output collection. These are my keys and these are my values. So in this fashion the job of the reducer is done, that is your aggregation. Might you have seen or not, the map method has not done the aggregation output. The reducer job is to do the aggregation, that is the reduction job that we call as a. So we have seen the mapper code for the temperature program, we have seen the reducer code for the temperature program. Now we are seeing the driver code, because the driver code is going to start the program, where you will be having a main method and you need to pass the input file, you need to give the output file name where the output, your result will be stored. So this is my main method. So where I am defining I am creating a job config object and assigning a job name for identification purpose. So this is my job config object. My object name is conf is my object name, and job name is temp. Temp is my job name. And setting configuration object with data type of output key and value. Conf.set output key class next.class, conf.set output value class int variable class. So this is about the configuration object with data type of output key values. Next is setting configuration object with the data type of output key and value of mapper. So for that purpose we are doing conf.set output key class, and we are passing the parameter as text.class, and for the output value class we are passing the parameter as int variable, int writable class. So now we are providing the mapper and reducer class. So since we are providing the mapper and reducer class, so because of this conf.set mapper class, map.class, conf.set reducer class, reduce.class, because of this when you run the program you will be getting 3 files, that is your temp.class file is one, temp map class is one, temp reduce class is one. So 3 class files you are going to get. So the map class file will be having the code of mapper, and the reduce class file will be having the reducing job. So since 3 class files are created separately 3 ways, so we need to merge them. So for that purpose we need to create a jar file. And output formats are, these are your output formats: conf.set input format text input format class, conf.set output format text output format class. And last we came now, this is very important, where I am passing my input file. file input format dot set input path. So my args of 1 is nothing by my input file. My input file will be whatever the weather data sets you are having or temperature data set you are having, temperature data set, whatever. And output file name is nothing but where your output is stored, that is your output file. So this is about the 2 arguments we are going to give when you run the program, and the entire process will start from here. The running is start from here. The running is start from here. Job conf dot run job. So when you say run job, this entire conf object, that is this is all your conf. Your setting configuration, providing the mapper, setting the format of input output, HDFS input output, everything is done in this conf only. So once you say run job method, it will run the job. All this job is present in the object called as a conf which you have defined. So this program is going to take the input data set as a weather data set, and it is going to find out the highest temperature of the particular year. So let us see now how the data set looks. This is my temperature data set. In the temperature data set, you can see here, this is my year, and in the year, this one temperature I have collected. This is another year, I have collected one more temperature. So you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So you can see that means here number of times I have collected up to it's almost all for maybe for 40 times or 50 times I have collected the temperature in the year of 1900. Now we have to find out which is the highest temperature. Similarly for 1903, 1904, 1905. So like that we have collected for, these are all my very big data sets. This is my temperature data sets. So you can see here, so 99, 2005, 7, 6, up to 2014. So 1900 to 2014, we have collected data temperatures, and now we have to find out which year it was the highest temperature, right? So this is my data set. So my temp.java program is ready and my data set is ready, right? Now let us see how to execute the program. So to do that, we are making use of terminal window, and then we will set the path, we will execute the Java program. After that, we will create a jar file because we get a three class files, so we need to compress them. After the jar file is created, whatever my data set temperature data set is available, that I have to send to the HDFS, and then you need to send your jar file to the data set and do the analysis. You can see here now I am opening my terminal window. Yeah, my terminal window is ready now. So as I said, we need to set the path for this jar file, Hadoop jar file, yes. So this is my jar file, Hadoop core 0.20 cdh3u 0.jar file, and this jar file I have copied. This jar file I have copied from the location called as root user lib Hadoop 0.20. From this location I have copied and I have pasted here. So what is my present location? My present location is, this is my present location. My present working location is, this is my present location, root home Cloudera. So I have pasted it, right? After this, you don't need to paste every day. Once you paste, it is okay. And this is also a jar file. It is also having its own importance. We will see that when there is a requirement of it. So let us set the class path. So I am setting the class path now. Yes, this is my class path. Because without setting the class path, if you run the Java file, you are going to see a lot of errors. So yes, as I said you that, lot of errors is there. So that is why we need to set the path. I am setting the path. Export class path Hadoop home, that means my present location wherever. This is my jar file. To the current location I am setting it, that's it. So once this path is set, now you can run the Java program. Now you are not going to get any error, that is your deprecated error viewer, that's not an error, no problem for that. That's a warning, right. So we have got 3 class files now. Let us see that temp.class. So you can see here, you have created a one Java program, but when you executed it, you got 3 class files, temp.class file, temp map.class file, temp reduce.class files, because you have written it for the map class, you have written it for the reduce class. So map will do the mapping job and the reduce will do the aggregation job. So these 3 class files are also, all 3 class files are also very much important. So we cannot run these class files separately, so we need to merge these 3 class files. We need to merge these 3 class files. So how can you merge these 3 class files? We can merge these class files by creating the jar file. So we need to create the jar file. So how to create the jar file? We will see now. So I am giving here my jar file, Hadoop jar. My jar file name is test temp.jar, and I want this jar file should be created at this location. I want that this jar file should be created at this location, so I have given the path like this. So now we have 3 class files. So these 3 class files we need to create a jar file. So how do you create a jar file now is jar cvf test temp dot jar temp star dot. In this fashion the jar files are created. So jar cvf, my name of the jar file is test temp dot jar. I am saying temp star dot class. So we have 3 class files. So these are the class files 1, 2 and 3. Now these 3 files I made together as one jar file. This is one jar file. This is my ultimate test temperature program, and now this jar file once it is ready, now it is ready, this will become as an algorithm for me. I can send this jar file to the HDFS where we have data. So I will send this jar file and they will do the analysis on this data, right. So that's what is going to happen, right. So my jar file is also ready now. Now what we are going to do is, as we have seen that we have a weather data set is there, that we are going to send to the HDFS. See, when you work on the real time environment, at that time you no need to send the data set to the HDFS, because that team will be working separately, that is going to be done by the administrators. So keeping the data in the HDFS location, all those things, job is done by them. So you no need to worry about all those things. That means creating the slave nodes, and basing on the size of the data sets, increasing the size of the slave nodes, putting them in the network, keeping this data on these slave nodes, all this job is done by the administrators. So you no need to worry about that. So you are going to just write the programs and create a jar file like this, and you are going to send this jar file to run on this data so that it can perform the analysis. What is analysis? This data is having the large amount of data, that is called as temperatures and the years. So what is the output we want? In which year what was the highest temperature? So when you work for the real time environment, you are not going to bother about keeping the data sets in the slave nodes. But since we are working in the pseudo distributed mode, so on one machine itself, we have to be as a master and we have to be as a slave. So let us see now how to keep my temperature data sets in the HDFS. So let us see now. Now we are keeping the temperature data set in the HDFS. So we have temperature data set. Yeah, my jar file is test temp jar is ready now. Now we need to work on the data sets. So let us see the location where my data set is available. I'll go to places, my computer, and let us see the temperature. Yes, this is my temperature data set is available. Right, temperature file. So now how to keep in the HDFS? Hadoop fs minus put, and this is my file name, temperature. Yeah. So once you give this, so Hadoop fs minus, so whatever you are performing the commands for the HDFS, you have to give the command, proceed with the Hadoop. Fs is a file system, put is nothing but putting, and this temperature is nothing but my source location and destination location. See, you have seen here, you have given the source, you have not given the destination, so we got an error. But what is the message we are getting? Target temperature already exists. So in the HDFS, this temperature file is already there, so it is giving this message. So it is not a problem for us. Now let us see in the HDFS whether this temperature data is really existing or not. So I am making use of this browser window. Go to name node status, because in the name node only data will be stored, and go to browse file system, user, Cloudera. So what is my data set? As I said you that my data set is temperature yes, this is my data set, temperature is available. Yes. So in the HDFS it is kept. So if you give the same command again, it's not a problem for us, just you are going to say that it's already available. So on this, so on the data, on the name node data is available. Now we need to send the algorithm. What was the algorithm you made? Test temp.jar file. That jar file you need to send here now. Right. So I am just closing this now. Now you are running the algorithm. Hadoop jar. My jar name is, jar file name is test temp.jar. My program name is temp.java. I'm just pasting it, because the file names are very bigger and we may make a mistake. You can see here Hadoop jar, my program, my jar file name is test temp, because test temp was created. Temp is my program name, my Java program name, this is my data set, and I am saying that the data set should be, the output should come to this file. So I am changing the output name, output temp, I am making as a output temp as 112, right. So when you run the jar file, what is going to happen is on the name node you have a data that is called as your temperature data set is available. So this jar file is having the mapper code and reducer code and driver code. So all these three things will come here and perform the analysis. So now I am running it. You can see here my MapReduce coding is coming here. This is your report risk. See, my map is now, you can see here only 0% is available, reduce is 0%, it's not started. Yeah, it's now 100%, reduce is 0%. That means job of map is completed now. That means intermediate key value pairs are created. Yes, that intermediate key value pair has been given to the reducer here, and reducer also done the aggregation job. So there were 23 counters, it seems like that. There were the reporting has been done, right. So what was the output file name we have given? Output temp12 is the file name we have given. So I am going to browse HDFS now, browser window, to see my output. Name node status, browse file system, user, Cloudera. What was the output file name we have given? We have given the file name as test op12. Yeah, we have got here output temp12, and in this we have got 3 files, success, logs, and the result will be stored in the part hyphen. This is the default file will be created. So 3 zeros, 5 zeros are there. So as I said you that the block size is 64 MB, that is the default size, and the output we got as this. So to see the output, you can just click on this and you can see the output here. So in 1900 we got 46, in 1901 we got 48 degrees, and remaining is as usual 49 degrees only we have. So like that we got the output for the many other years. So let us see the output for last one. So last one you can see here 2014 15 degrees, that is. Similar outputs we got for the many other same years, but last year we got different output. But if you go to the first year again, to the 1900, it was 46 degrees and 48 degrees. So remaining is almost all same output we got, because the data set has got same values almost all. We have just done this. So that is about our weather data set, how to execute that we have seen. And as I have given the program name as the job name, I have given as temp. You can see here the job name will be here, the job tracker status. If you go to the job tracker status, this you can see here we have map and reduce. So map has done 100%, reduce has done 100%. You can see the graph also. So that's what about our today's class. So we have seen how to execute the weather data set by writing the MapReduce program, and we have performed the analysis on the weather data set, and through the weather data set we have performed that in which year which has got the highest temperature. So thank you so much for listening to the class. We will meet in the next session.